Okay, so we're going to be recording this now. And what we did last time was we talked about how the number that would be in front of, and I'm going to use a red pen here to show this, the number that would show up right in front of the function. In other words, the number that shows up right after the equal sign is going to tell us something about how the parent graph will change. And do you remember, based on what we saw last time, if that number is bigger than 1, what does it do to the graph? Does it make it stretch vertically, or does it make it shrink?
Stretch.
If it is a number that's greater than 1, it makes it stretch vertically or get skinnier, right? If the number is between 0 and 1, what does it do to the graph?
Make it wide.
Yeah, it's kind of like a trash compactor. If you think about this, it's going to, as it pushes down this way, it's got to go somewhere. So it's going to go out wider. So you're going to pay attention to what number shows up right after the equal sign. And that's going to tell you about vertical stretch, vertical shrink. If there's not a number there, it means that that part of your equation has not changed from the original. You're not going to have to put these graphs on a paper. You're just going to have to look at the equation and be able to answer for me, did it stretch or did it shrink? Okay, so far so good. We're also going to look at reflections. Excuse me, and that's going to be if you see a negative sign that shows up right after the equal sign. That's going to tell you that the graph will reflect or flip over the x-axis. And we kind of already know that, because if I gave you, and we talked about this last time, if I gave you an equation that looked like this, well, come on now, there we go. That wants to wiggle on me, never mind. If I gave you an equation that looks like this one, the y equals negative x squared, you guys already know when you look at it, which way does that parabola open, up or down?
Down.
Down. Very good, because that's what that negative sign is telling us is going to happen to it. If it's positive, it tells us it opens up. Now, we also discussed that it has to be the y equals x squared in order for it to open up or open down. Do you remember what happens if instead of y equals x squared, it was an x equals y squared? Which way does that open?
Follow.
Say it again.
Follow.
It's going to open to the right, sideways, right? This one, I'm just going to stick it here, would look like this. Okay, and that one's not going to be a function, is it?
No.
Okay, so we got to pay attention. As long as it's a y equals x squared, we know it's opening up or down. The negative would tell us it opens down. The positive would tell us it opens up. But we got to pay attention. If it's an x equals y squared, it's going to go side to side. If it's positive, it opens to the right. What do you think would happen if that were a negative in front of the y squared? Instead of opening to the right, it would open to the
Left.
left. There you go. Okay, and then this is where we talked a little bit about symmetry, and we mentioned things being symmetric to the origin, which is more of a rotational symmetry, but I'm not going to give you any of those questions on the test. Instead, we're going to pick up, and we're not going to talk about even and odd. We'll just not worry about that, but I do want us to cover these translations. These are kind of important to know, and we're going to be able to learn some things just by looking at where these numbers show up in an equation. Now, look at this one right here. F of x equals x squared plus 2. First of all, can you tell me what is the parent function here? if I were to ask you the basic shape of our graph, what's it going to be?
For you.
A U, because this comes from y equals x squared. That's the parabola, which we know is going to be this U shape. Agreed? Yes. So is this parabola going to open up or open down?
Open
And I
up.
want you guys to do this on the chat. Go to the chat and you're either going to type in up or you're going to type in down. And that way I'll be able to tell if you know. I've got Patrick's answer. Okay. Good. Looks like everybody's got that one figured out now. Okay, so my question is, what's different on this is now we see a +2 at the end. So what do you think that +2 is going to do to my graph? It's
Move
in,
it to the right.
You started on 2.
okay,
180.
so because these are translations, here are our options. We've got 4 things that can happen depending on where our number shows up. It can make it move up, it can make it move down, it can make it move right, or it could make it move left. Why don't you type in the chat box which way you think this thing's going to go? Is it going to move up, down, right, or left based on that +2 that's at the end? Okay, so it looks like we're either, the 2 votes that I'm seeing are either right or up. And I'd say those are logical guesses because it's a +2. I don't think it's going to go down and I don't think it's going to go to the left. It would make sense that it's going to be one of those 2 things. So here's what we're going to do. We're going to go to the calculator. Let me clear this out. And we're going to put in 2 things. First of all, let me fix this so it will not be, oops, hold on. Okay. Okay. And let me fix this one real fast. Okay, so we're going to make the blue one our parent, just the y equals x squared. But then we'll let the red one graph and we'll make it y equals x squared and we'll put that +2 at the end. Okay, let's see what it looks like. Here's the regular and there's the red. So when you put a +2 at the end, what did it do to the graph? It went up. Very good. That's what I wanted you guys to see. Now, I'm going to go back to the notes. And what you're going to have to be able to tell me, if this is a test question, is it's probably going to look something like this. The graph shifts, and there's going to be a blank there. And you're going to have to choose up, down, right, left. And this is going to be on a section, you don't get to look at your graph. You're going to have to look at the equation, and you're just going to choose which one of those goes in the blank. So the fact that there's a +2 at the end is going to tell me that I've got a vertical shift. If it's positive, it means it goes up 2. What do you think would happen if that had been a -2?
Went down.
It would have gone down 2. So it's very logical. Whatever number is added at the end, if it's positive, it's going up that many units. If it's negative, it's going to go down that many units. Make sense? So if we go to this part of the notes to fill in the blank, it's telling us when we get this +C at the end, then there is going it's going to end up being translated C units up if C is positive, or C units down if C is negative. Okay, and this is called a vertical translation of our graph. Okay. Now, tell me what's a little bit different on this one.
It's squared.
Yeah, here's what I want you to notice. This is saying take your parabola, your y equals x squared, that parent graph, and then with the +2 being at the end, it means take that same shape and you're just going to move it up 2. The square was only happening to the x, but look at this. The square is on a parentheses, and in the parentheses, we've got x +4. So in other words, the +4 wasn't happening to the whole function. This +4 is happening just to the x, okay? So it's changing x before it is squared. Now that's going to do something different to the graph. Or is it? Do you think it's still just going to move up 4, or is it going to do something else? So again, pull up the chat, and I want you to tell me how you think it's going to move. Is it going to move up, down, right, left, and how many? Okay, so I'm seeing some up, I'm seeing right 4. And some of you are either not sure or you're thinking about it. Okay, now I've got some who are saying maybe it's going to the left. All right, let's look at this thing. So here's what I want to do. I'm going to go back to the calculator, but I'm going to make this change. I'm going to go back to my y equals. I'm still going to leave that parent in there, the y equals x squared. But now I'm going to type in my parentheses, my x +4 inside the parentheses, and then that's going to get squared. So let's see what it does. Here's the original. Oh my, what happened? It went 4 which way?
Left.
To the left. Now, here's what I want you to see, because this is the part we're going to have to get comfortable with. When something happens just to the x, okay, you have to think backwards. So if it's not happening to the whole function, in other words, it's not showing up at the end, but it happens to the x before everything gets squared, or everything gets cubed, or everything gets square rooted, I'm going to have to think backwards, because I would normally think when I see a +4 that that's either going to move up or to the right. Since it's happening just to the x, that's telling me it's horizontal, so it's got to move right or left, but it's going to be the opposite of what I expect. And the one way you can think of it is if I took that x +4 and I set it equal to 0, that's going to turn into x equals -4. That kind of lets you see, hey, this thing is moving left 4. So if it's in a parentheses and it's happening just to the x, then it's going to be the opposite of what you're expecting. This is going to move left 4. What do you think it would have been if it had looked like this? Suppose it was f of x equals, and I would have x minus 1 in parentheses squared. What do you think that would cause it to do?
Go to the right.
Go to the right how many?
1.
So that would move to the right 1. Make sense? You're going to have to study this to make sure you get it down. So I really don't like the way this thing is worded on horizontal translations. Basically, I'm just going to tell you, think opposite. So if I see, let's say we have f of x equals, and we've got x plus 2 in parentheses squared, this is going to tell us that it moves which way?
To the left.
Moves left, how many?
2.
2. If it looked like this, and we had x minus 5 in parentheses squared, it's going to move
To the right 5.
to the right 5. Okay, I want you guys to send me a quick chat answer, or you can unmute yourself. So far, are you good? Is what we've talked about so far something that makes sense? Because we've talked about from last class, what we started with was the vertical stretch, vertical shrink. Then we talked about the negative sign makes it flip over the x-axis if the negative is right in front of, or it comes right after the equal sign, I should say. And now we've talked about if something's going to shift up or down, or if it's going to shift right or left. So do you understand what you'd need to look for and feel okay with these rules? And either tell me, yes, I'm good, or not too much, or tell me what you need.
Pretty good.
Okay, so got a good from Logan. Anybody else?
Good.
Good, okay.
Good.
Good. And I've got answers from Morgan, Kasai. All right, so we're going to be practicing on this more, but that's what we've covered. So here's a little table that let's fill this part in. Everybody is back to the notes, right? Can you see the notes? Just make sure I've got the right screen up. Yes?
Yeah.
Okay, good. All right, so see if you can tell me if y is equal to whatever my function is, and then I see plus a number at the end. What way is this thing going to move? C units, which way?
Up.
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 When it's at the very end, that's going to be my up or down movement. Okay? So the minus C on the next one tells me it's going to move
Down.
down. Good job. Now, what if it's happening just to the x? Excuse me, if it's in the parentheses with the x, if I see x plus c, I'm going to go c units which way?
Left.
I heard one left. Anybody
Left.
else? Very good. Remember, that's when you have to think opposite. When I see that it's happening just to the x, if it's plus c, I'm actually going to go to the left. If it's minus c, I'm going to go to the
Right.
which way? To the right. Okay, so here's what we're going to do. I've got some equations. I'm not going to ask you to graph it, but I'm going to ask you to identify all the different transformations we see here to describe what's going to happen to this. Now, can you tell me, just looking at this entire equation, if this thing's graphed, what's the basic shape going to be? Remember, we've got those 6 equations that we've studied. So what do you recognize about this? It's going to be what kind of basic shape?
U.
Okay, I hear somebody saying U. What do you think? Anybody else? All right, so can you tell me why you say it's going to be a U shape? Okay, I need some help here. When you say U, are you talking parabola?
Yeah, it's a parabola.
And the reason is why. What is it about the equation that tells you this thing's going to be a parabola?
Square up.
Yeah, the square. That's it. When I see that I've got an x that's being squared, even if the x is in a parentheses, that's what tells me this thing is quadratic, and it's going to be a parabola when I graph it. Okay, so I see a number of different transformations going on in here. We're going to take turns, and I'm going to let you decide. If I get a volunteer, you can pick out of all the different things going on to this parabola. I want one person to tell me one transformation that when you look at it, you know this thing is going to do, whether it's going to open up or open down, if it's going to shift right or left or up or down, if it's got a vertical stretch or a vertical shrink. Those are all the things we're going to look for.
It's
So
opening down.
Okay, so is that Patrick that said open down?
Mm-hmm.
And Patrick, tell me which part of this is letting you know that it opens down. What tells you that?
The negative.
And it's the negative in the very beginning, correct?
Correct.
Excellent. Okay, so Patrick can't answer any more on this one. New volunteer, do you see something else in this that you know how it's going to move? What was that?
It's gonna move to the right one.
Okay, Jakarian says it's going to move to the right one. What's telling you that? Which part of the equation?
Parentheses squared.
The part that's in the parentheses with the x. Excellent job. This tells you it moves right 1 unit. Because whatever happens to the x, you have to think opposite, right? Okay, so Jakari and Patrick can't answer anything else. I think I see another transformation. Anybody want to identify something you might see? Maybe one of you ladies. Kasai, Morgan, Taylor. What else is in here we haven't said what it does?
Is it the up 4? Like it's like over, but it's up 4. Like
Good job, Taylor. The +4 at the end tells us that it moves up 4. Does that make sense? Now, does this thing have any vertical stretch or vertical shrink? And that's just a yes or no. What do you say?
No.
And why would you say no?
I don't know. I just guess.
If it did, wouldn't I have to see a number after the equal sign but before I get to the x? Yes, and there's no number there. It's just negative. It means -1. So there's no vertical stretch, no vertical shrink, but we do have these 3 transformations. So that tells you you don't have to have all 4 of them at the same time, because we can have vertical stretches and shrinks. We can have reflecting over the x-axis, whether it opens up or it opens down. We can have moving left, right, or we can have moving up, down, but we don't have to have all of them on every problem. So let's go to B. And at this point, we've had Taylor and Patrick and Jakarian answer something. So that means I've got Logan and Tate and Kasai and Morgan. I want y'all to look at B. And I want one of you to pick something out of this equation here and tell me what you recognize is going to be different from the parent. First of all, can somebody tell me what's my basic shape on this one? What kind of equation is it?
Isn't it like a V?
Very good, Patrick, because what is it that tells you it's going to be a V?
The two lines.
The two lines, the absolute value bars. Very good. So absolute value graphs is a V shape. Now, between Logan, Tate, Kasai, Morgan, one of you guys tell me something you identify here that tells you one of those transformations. Kasai, do you recognize something? What would this negative in the front tell us?
Wouldn't that make that upside down?
So Logan, when you say it would make it upside down, that's telling instead of a V opening up, it's going to be a V that opens down. Good job.
And wouldn't the plus 3 put it to the left by
Okay.
3?
Okay, so what do y'all think? Is Logan right? He's saying this plus 3 that's inside the absolute value bars with the X, so it's happening just to the X, that's going to go 3 units which way? And how about Tate? Can you say which way you think it's going to go? Tate, are you still there? See, this is why I like for you to have your cameras on, because otherwise you can walk out of the room and make me think you're still there when you're not. So Kasai, see if you could answer that part. If it's got the X and it's got plus 3 after it, Logan says he thinks it's going to go to the left. Do you think that's right? I shouldn't say right. Do you think that's correct? Because what happens to the X is the opposite of what we see, right? So it moves 3 to the left. Is there anything else going on here we haven't identified? What do you think, Morgan? Do you see something?
I'm not sure.
Well, I've used the negative sign that comes after the equal sign, and I've used the plus 3 that's inside the absolute value bars. What I haven't used is this 2. What could that 2 be telling me? This graph is going to do what? When there's a number after the equal sign, but before you get to the X, it's telling me that I've got what? It was the first thing we talked about last class.
Is it going to move left? I don't know. I don't know.
What we talked about is it's either going to be a vertical stretch or a vertical shrink. Which one do you think this is?
Shrink?
Somebody help her out. Remember, when we see that number after the equal sign, we got to decide if it's a stretch or a shrink. And it has to do with whether the number is bigger than 1 or the number's between 0 and 1. Kasai, do you know which one you think it might be?
Hold on.
Stretch.
Wait, what are we looking at again?
We're looking at the 2 that comes after the negative sign on B. It's going to be a vertical what?
Stretch.
Stretch. Because if the number is bigger than 1, it's going to be a stretch. Does that mean it's going to look skinnier or it's going to look wider?
Skinnier.
Skinnier. There you go. Good job. Okay, we've got one more of these to do. Everybody's done at least one at this point, so this will kind of be fair game. I'm going to let it actually, let's try this. No, let's don't. Okay. Somebody tell me one thing you recognize. Well, first of all, somebody tell me what kind of graph this one's going to be. What kind of function? What's it called, this function? It's the, what's that symbol in there?
Square root function?
It's a square root function. And a square root function is half of a sideways parabola. Okay? Now, somebody tell me one transformation you see in this.
It goes down.
Okay, so Patrick, tell me one, say that one more time. It does what?
It goes down 3.
Okay, and tell me which part of the equation is letting you know that.
The -3.
Okay, so Patrick says that goes down 3. Y'all just unmute yourselves for a second. Tell me, is he right?
Yes.
Yes.
Yes, he is. Very good. Those are usually the easiest ones to spot. If there's plus a number or minus a number at the end, you got it. Okay, somebody pick another transformation that you recognize.
It's a vertical, not a vertical stretch, but the other one.
The vertical shrink of how much?
Right.
Half.
Yeah.
Yeah, because this 1/2 that comes right after the equal sign tells me I've got a vertical shrink of 1/2. Now, can you tell me why you knew it wasn't a stretch, it was a shrink?
Because it was lower than 1.
Very good. When it's a
Oh,
number
yeah.
between 0 and 1, that makes it a shrink. If it's bigger than 1, it makes it a stretch. Okay, we got one more transformation to go. What is it?
It goes left 2.
Okay, Patrick says left 2. Do y'all agree?
Yep.
Yes.
And because when it's happening just to the x, notice the only part under the square root is x plus 2. So that plus 2 happens to the x before anything else happens to the x. And that plus 2 lets you know this thing's going to shift left 2. All right. Does this part seem like it's not going to be too bad? If I give you an equation like this and ask you to tell me how it changes, can you identify those transformations?
Yeah.
Yes.
Very good. And this part here is just explaining, if you were going to put it on a graph, you could actually kind of take it and move it over somewhere, put it up, whatever. It doesn't even have to be, I mean, it could be any shape. We're not going to do that, but we are going to fill in this table and see if we can figure this out. So if you have this equation that plus k is telling you you're going to move k units which direction?
Up.
Left.
Up. Because when it's at the very end, that's an up-down move. So if I have this function minus k, I'm going to move k units which way?
Down.
Down. Good job. Now, if there's an h in the parentheses with the x, we're going to move h units which way if it's x plus h?
Left.
Good job. But if it's x minus h, you're going to move h units to the
Right.
Right.
because it's opposite when it's happening to the x. Now, if I see that there is some number in front of the function, a number that comes right after the equal sign, as long as the number's bigger than 1, what does it do to the graph?
Stretch.
Vertical stretch.
Good, vertical stretch. But if the number's between 0 and 1, it's a what?
Vertical shrink.
Vertical shrink. Good job. Okay. We did not do horizontal stretches and shrinks, but we did do this. So if there's a negative sign that comes right after the equals, then what instead of like let's put it this way. We said as long as it's something like a parabola or an absolute value, we can just say it opens up or it opens down. Technically, what's happening if the negative comes right after the equal sign, it reflects over which axis?
The x-axis.
The x-axis. If the negative happens only to the x, and we're not really going to get this on a test question, but I'll go ahead and fill this in for you, it makes it reflect over the y-axis. Now, depending on your function, sometimes when you reflect over the y-axis, it makes it look the same. So that's not as common for us to do that, but I wanted to cover that. So that's all you really need to know out of 2.7. Does that make sense? Okay, we're on to the last section. Excuse me. In 2.8. Okay, so here's the updated plan. For those of you who had any trouble doing the quiz in my math lab 2326, I have re-enabled second attempts for those of you who took it the first time and maybe something happened, like you quit before or it kicked you out, because you get 2 attempts. So everybody should have your second attempt enabled if you've already tried it. If you haven't done it at all, you need to go in and do the quiz in my math lab. It's due by tonight, and that's over 2-3 and 2-6. So
Are you
that's
talking
making
about
sure.
the Kahoot quiz?
I'm sorry, what?
Are you talking about the Kahoot quiz or the?
The Kahoot quiz is open through tomorrow night, and that is one that you get 100 just for doing it, but you can do it as many times as you want to practice making sure you recognize all of those parent functions. That's the whole
The
point
one
of
you're
doing
talking
it.
about is the interval notation, right?
The one I'm talking about is in my math lab. It says 2-3 and 2-6 quiz, and it covers is it a function, what's the domain, what's the range,
Okay.
which means some of it you do answer using interval notation, and then recognizing those parent graphs. There are 2 attempts. So if you do it the first time and your grade's not that good, you can go back in and do it a second time, and it'll keep the higher of the 2 grades. Okay, so make sure you take care of that. Now, we're going to try to finish up these notes today on 2-7 and 2-8, and that's all we're covering out of chapter 2. We don't have 2-8's pretty small, so we're going to get through this. One other thing I want to show you, and I'll go ahead and take you there right now. In our Canvas course, let me go to the dashboard and show you. You want to go over to where it says modules. And if you look here where it says chapter 2, remember this is where the notes are if you want to print them out at home, or if you just pull them up and like write on them in the computer like I'm doing, that's fine. This is where you find all the videos that I've done from other classes that you can watch. And then this is where I'm putting our meetings that we're recording right now. But I've now got a new one in here that says chapter 2 review, and I'm going to send a message out to everybody after class so those that weren't here will know about it. When you click on it, you're going to get it's the same page I would hand out if we were in class. And I want you to have this ready for Monday, because when we have class on Monday, we're going to go through and work on all these together. Now, it's going to be a lot better if you've already worked on it, and then you can come in and we can go through the how to do it. And I'm going to get you guys to kind of, sort of like we just did a second ago, where I'm going to call on some of you to tell me, okay, what would you put here, or what's the answer on this? And we're going to work through the whole thing together, because by next Wednesday, we should be ready to do the chapter 2 test. I'm still working on exactly how we're going to do it. I don't think I've gotten anybody, and correct me if I'm wrong, have I gotten anybody yet who has said the only way I can do anything is with my cell phone? All of you who are logged on right now, is your only access with your cell phone? If anybody, if there's anybody that's true, tell me yes. Otherwise, I'm going to assume you've got other things. Tate, do you
It
just have a
depends on my
phone?
internet, unfortunately.
So your issue is kind of sketchy internet, right, Logan?
Yes, ma'am. I lucked out today because everyone's gone to their work, but if I have any sort of interference, I would have been lagging out and being disconnected every 5 minutes.
Okay, so that's good to know. Tate, what about you?
My what?
Do you have access to any, only with your phone, or do you have other access?
Oh, no, I have a laptop.
So you do have a laptop and internet.
Yes.
Okay, what about you, Kasai?
Oh, I'm good. I have a laptop.
Okay, so what I'm kind of thinking that we may do, I told you guys that we'd probably do part of it with like a take-home test, and then part of it where we're going to do more or less Zoom proctoring. okay? And I think that's probably what we'll do on this first test. Now, your final exam, I'm hoping to have you guys take it in something called Honor Lock, which would mean that you can't use your cell phone. You're going to need internet and a device, but there are places where you could go for a hotspot if necessary. When we get to that, you might have to sit in your car to do it. I don't know. We'll work on that by the time we get to final exam. But for this test, I'm thinking we're going to try to do it where half of it's going to be take home, half of it I'm going to proctor with Zoom, which would mean like right now you've logged in, you'll have to turn on your camera and you'll have to have it positioned so I can see you, and then you're going to watch the screen for the problems to come up and you're going to write it down. And as soon as the test, you're through with the test, then you're going to have to submit your work to me in a message. Does that make sense? And the plan is to do that next Wednesday, the part that we do with Zoom meeting. All right, does that make sense?
So we're gonna review Monday.
Monday, we're going to do the review. So we're going to finish up the notes today. Monday, we're going to do this review sheet that I've got on the screen. Well, I say we're going to do it. I'm going to hope you've already done it, and then we're going to go through it together to cover any homework questions you have, anything on the review worksheet that you want to go over. Because if you can do what's on the review worksheet, then you should be in good shape as far as the test is concerned. Okay? I will tell you, and I meant to take this off, I may go back and fix that. 13 and 14 we're not doing, but everything else that's on here we will do. So I'll see if I can fix that and get 13 and 14 taken off, and then I'll reload it. Okay? So that's going to be the plan on how to test, and I'll get that out in a message to everybody else who's not here. Okay? We're going to see how this works. I know we're all having to do things kind of not the normal way right now. So let's go ahead and finish up with 2.8. We're looking at operations with functions and composition of functions. So let me kind of explain real quickly. This first part, I think you're going to think is not too bad because it simply means if I've got two different functions, I can add them, subtract them, multiply them, or divide them, okay? And the way that's going to happen is I'm going to give you a problem that's going to look something like this on A, okay? And you may be thinking, well, what am I supposed to do with that? Well, all you're going to have to do is this. You're going to take f of 0, which means I go to the function that says f of x, and what do? 0 goes in for what?
For x.
For x, that's right. So I'll take the f of x function and I'll put in 3 times 0 minus 4. Now, solve that for me. What is 3 times 0 minus 4?
-4.
-4. Then I'm going to have to do what? What do you think? I'm going to go to the g function and I'm going to find out what g of 0 is. So I'll put in 0 for x in that one, and that's 2 times 0 squared minus 1. Well, what would that equal?
-1.
Because order of operations tells me do the exponent first. I'm squaring 0, which is 0. 0 times 2 is still 0, and 0 minus 1 is -1. So what that means is if I add these two together, -4 plus -1 is?
-5.
And that's my answer. That's all you're going to have to do. If this had been f minus g of 0, what would I need to do? -4 minus -1 and clean it up, right? I can do any operation. If it had been f times g of 0, then I could take -4 times -1. Does that make sense? All I'm going to have to do is evaluate each one of these for whatever number it tells me to use for x, and then go back and do the operation that it asked for. So let's try this one on B. Let's do the f of 4. I want you guys to do that. You're going to tell me what that's going to equal. Don't say it out loud just yet. Come up with an answer. And then in a minute, I'm going to have you guys tell me. Okay? So while everybody's working on it, I know there's probably a few of you that already have a number. So answer this for me. Did you come up with something that's a 1-digit or a 2-digit number for your f of 4?
1 digit.
Okay, I'm hearing 1 digit. Was it positive or was it negative?
Positive.
Positive. Okay, does everybody have an answer now? Unmute yourself, because everybody unmute. I can see 1, 2, 3, 4 of you are still muted. There we go. There we go. Okay, so on the count of 3, I want you to tell me what number you think this is. 1, 2, 3.
8.
8.
Good job. Because I'm going to plug in 4 where the x is, and 12 minus 4 is 8. Okay? Now, let's do the same thing for the g function. See if you can come up with g of 4. But don't call it out just yet. Okay, so those of you who are working on it, this time did you come up with a 1-digit or a 2-digit number?
Cool.
Okay, so I'm hearing most of you say 2. Was it positive or was it negative?
Positive.
All positive.
Okay, so on count 3, I want you to tell me what it is. 1, 2, 3.
31.
31.
All right, good. Because I'm going to plug in 4 for x and then clean up using order of operations. So what gets squared? Just the 4, right? And 4 squared is 16. 16 times 2 is 32, and 32 minus 1 is 31. So if you had to answer what is f minus g of 4, what would you tell me?
-23.
Because I'd have to take the f first, which is 8, minus the 31, and that's going to be what number? One more time?
-23.
Negative 23. Okay, so do this for me. Either go ahead and put your video on, and I want you to either give me the thumbs up or the thumbs down. I just need to see your faces. Okay, got Jakarian. All right, Kasai, good. Logan, good. Taylor. Tate, did I see your thumb? I can't remember.
I can't even tell if my camera on right now.
Your camera's on. Okay, Patrick, got you. Okay, so, but you're good, Tate?
Yeah, I'm good.
Okay, all right. So tell me what it's asking you to do on C. What operation? What does that mean when it's just FG in parentheses? Say it one more time.
Multiply.
Multiply. Okay, I want you guys to see if you can come up with an answer on that one.
All right.
Okay, we're going to take just a second to do that, and then we're getting close. And in fact, this time, when you think you have figured out what the answer is, I want you to send it to me in a chat.
You like
Yeah, send it to me privately so not everybody sees it.
Are we giving you the answer like all together at
Yes,
the
the
end? Or
final answer all together. We're going to work it all the way to the end. Okay, got one from Jakarian and from Patrick. Taylor, Logan, Morgan. So Kasai and Tate are the only two I haven't heard from yet. Okay. I will tell you, the majority of you gave me the right answer, which is awesome. Okay. And actually, I think the one who had a little misstep caught it and fixed it. So if I plug into the f function, 3 times negative 2 minus 4, when I clean that up, 3 times negative 2 is what?
-6.
And negative 6 minus 4 is a negative 10. Did y'all get that?
Yes.
Good. Now, in the g function, 2 times, I'm going to take negative 2 and square it, and then I have to subtract 1. Now, when you square negative 2, it turns into what?
4.
Positive 4. And 4 times 2 is 8, and 8 minus 1 is
7.
7. If I multiply these two together, the answer is
Negative 70.
negative 70. Makes sense? Okay, and when it's a fraction, just to save time, let's do this. Let's go back to what we had on A, and instead of putting a 3 there, let's just see what we would get if we did f divided by g of 0. So what did we say f of 0 was? If you go back and you look at A, that way we don't have to recalculate. We'll just use numbers we found.
-4.
That was negative 4, wasn't it?
I mean,
And what was
Yeah.
g of 0?
-1.
-1.
So what's that going to turn into?
0.
Well, look carefully.
I mean,
Negative 4 divided by
Negative
negative 1 is
positive. I mean,
positive 4. The negative divided by a negative gives me a positive. So we're just doing whatever the operation is and cleaning up. Okay. Now on this, we're not doing this part because the only time I'm going to ask you to do it is when there's a number involved. But sometimes instead of giving you the equations like that, you might have a graph. Now I want to make sure we can read these off the graph okay. Let's see if we could figure out what f plus g of 1 would be. So what is that asking me to look for on here? I need f of 1 and I need g of 1, right? Now that f function is which part of this graph? I see two functions going on here. I see that v, which is the absolute value, and I see what else? A parabola, right? Upside down parabola. So which one is the f function? The absolute value or the quadratic?
Quadratic.
The quadratic is the f function. I know that from looking right here. So if I look for f of 1, do you have any idea what that value is?
4.
What's that telling me to
F1.
do? Okay, we need to review this. It's saying find the what. Remember, f of x is the same thing as y. So f of 1 is telling me find the y value when x is what? 1. So I've got to look on the parabola for where x is 1. So what I see is it's right here where there's an x value of 1, and that means the y value is what?
3.
3. That's what it's asking you to do. Now go to the g function, see if you can figure out what g of 1 is.
1.
2.
All right, we're not in agreement, are we? Taylor, you're right. It's 1, 1 is the point on that graph. So when x is 1, y is 1. And maybe I need to blow it up a little bit more because it may be too hard to see. Okay? So on that V, 1, 1 is on there. So if f of 1 is 3 and g of 1 is 1, what's f plus g of 1?
4.
3 plus 1 is 4. Let's try another one because I think the graph is usually what gives most people trouble. It says, let's find f times g of -1. Okay, so let's look at the graph here. Can you find f of -1? When x is -1, what's the y value on that parabola?
3.
Do y'all agree?
Yeah.
Yeah, Jakarian's right. When x is -1, y is 3. Now, what is g of -1?
-1.
Is it -1?
Yep. Yep.
Yeah.
Look, guys, it's right here. What's that y value? That's not -1. That's what? X is -1. What's y?
Oh, it's 3.
Positive
Negative.
1.
Oh, I mean, yeah, positive 1.
Yeah.
Oh, yeah.
Look at that. Does that make sense?
Okay, yes.
Okay. So what would f times g of -1 be?
3.
3. Okay. I think we need to practice one more of these. Let's go to, okay, let's do this one. We'll try division. It says f divided by g of -2. So let's see if you can figure that out. We'd need f of -2 first, and then we'll go get g of -2. Okay, so what do you think f of -2 is?
0?
Good job, 0. When x is -2, that's the point where the parabola is crossing the x-axis. The y value is 0. Now, what's g of -2?
Positive 2?
Positive 2. So if I put this into the division, I get 0 on top over 2. What does that equal?
0.
0.
Good job. Now, I'm curious. What if this had said g divided by f of -2? What would have been different on that?
0.
No real number or something.
Oh, very good, Patrick, because the 2 would have been on top and the 0 would have been on bottom. And since we've got 0 in the denominator, that is undefined. That's not a number. Empty set. Can't happen. Okay, because we can't divide by 0. All right, so hopefully we practiced a little bit of reading off the graph. Look at B. Let's try, well, let's do the f plus g of 1, reading off this table. Do you have any idea how to find that? What would f of 1 equal?
1.
Good. You're exactly right. When x is 1, f of x is 1. What is g of 1?
6.
Yes. So what would f plus g of 1 be?
7.
7. I just add them together. What if this had been f divided by g of 1? What would that have turned into?
Divided by 6.
1 divided by 6. You're right. It would just be a fraction. 1 divided by 6. Okay, so reading out of a table like that, is that no big deal?
Nope.
All right, and then the last one that's on here is like what we were already doing as far as we had equations and we put in numbers. We're on the last page, guys. You're almost done. So composition of functions. This one is kind of an important idea. It's the idea that I can actually take a function and put it in for x into another function. Okay, it sort of like, think about it this way. It probably has been a long time since you've ridden, say, a 10-speed bike. But if you think about how gears on a bike work, when you switch gears, don't you have all these sprockets that the chain is hooked onto on the bike? You know what I'm talking about, right? And as I'm switching gears, what's happening is you've got, usually you've got, well, you've got more than one sprocket that the chain gets hooked around. And so as you're connecting these two different sprockets together by the chain, that's what is controlling whether you're going to have to pedal harder or whether you're going to have to pedal, you know, faster. Whether, you know, that gives you the ability to gauge whether you're going up a hill or you're going down a hill, how you can control things better. And it's because you've got a function within a function. That one gear that you switched over to is now controlling how fast the other gear is moving, and the chain that connects them is what keeps it together. So there's a lot of things in the real world that use this concept. And really, when you see this little open circle, it doesn't mean times, it's not multiplying, but that open circle is telling us we're going to take this inside function, whichever one of these is closest to the x, and that whole function is going to go in place of x in the outer function. Now let me show you what I mean by this. If it's written this way, f, and you got the little circle g of 2, that's the same thing as doing f, open parentheses, and then put g parentheses 2 inside. So what that's telling me is that I'm going to have to find g of 2 first, and whatever number that is, I'll put that number into my f function. Does that make sense? Y'all give me either yes, no, something.
Yes.
Okay, so I've got it, just like we've said with parentheses, you work your way from the inside out. So I'm going to find g of 2 first. And g of 2 is going to equal, according to this, it's 2 over x. So 2 over 2 is equal to what number?
1.
1.
1.
Since g of 2 equals 1, what I have to do now is take 1, and I'm going to put it in place of g of 2, and that goes into the f function. So I'm actually finding f of 1 now. Does that make sense? I had to find what g of 2 is equal to, and I'll take that number and I'll put that number into my f function.
Yes.
And so now when I plug in, I've got the square root of x plus 4, so that'll become the square root of 1 plus 4, and that's equal to what?
5.
Square root of 5.
Yeah.
That's my answer. That's all I'm doing. Okay. Now I want to show you it makes a difference. I can't switch the f and the g. If I reverse order, I'm not going to get the same thing here, because this is telling me I'd have to find f of 2 first. Well, my f function said take the square root of x plus 4. So that would be the square root of 2 plus 4, which is the square root of 6. And that's the number that would have to go into the g function. But my g function said take 2 divided by whatever that number is.
So 2
That's not,
divided by the square root of 6?
yeah, that's not the same thing as the square root of 5, is it?
No.
Order matters here. It's going to be very important that you don't mix these up. I have to do it in the order that it's given to me, where I'm first going to plug in to whichever function was closest to my x, the number they gave me for x, and then that answer gets plugged into the outside function. So now let's try this. We've still got these same two. I want you to see if you can find g of f of 5. And when you think you've got it, send me your answer in a private chat. G of f of 5. Okay, I've got 2 answers so far. Three. Make sure you work all the way to the end. You're sending me your final answer. Can you do that? Okay. So I've heard from 4 of you. Okay, and Jakarian, see if that cleans up a little bit. You're almost there. You just need to simplify. There you go. Okay, so let's go ahead and work this thing out. Somebody tell me, what's the first thing you have to find?
F.
F of
5.
5. Good job. Okay, so when I go to the f function, that's the square root of x plus 4. I'm going to put 5 in place of x, right?
Yes.
So how much is 5 plus 4?
3.
Well, 5 plus 4 is 9, right? And the
9, yes.
square
My
root
bad.
of 9 simplifies to be what?
3.
Good job. Okay, so that means what number, what am I going to do now?
Plug it in.
Find the G with 3.
Exactly.
With
F
5.
of 5 is 3. So I'm going to put 3 into my G function. And I get 2 over 3. And that's the answer I was looking for. All right. We have covered the notes now. The plan for the rest of the week. If you haven't yet done it, what are you going to make sure you take care of in my math lab?
Do it.
The quiz.
The quiz, 2.3, 2.6 quiz. How many times can you take it?
2.
2 times. If you haven't practiced with that Kahoot on making sure you know your parent functions, you want to make sure you do it, okay? And how many times can you do that one?
As many as we want.
As many as you want, okay? But to get credit for doing it, to get the 100, I have to know who did it. So you have to make sure you use your full name at least one time. If you want to go back and do it more times, you can use other names if you want. But I got to see your full name at least one time for you to get credit on it. And then what else are you going to make sure you work on before Monday? The review sheet, right? that chapter 2 review that I've got loaded into, do you remember how to find it in Canvas? Yeah. Where do you go? What do you have to press?
Modules?
Thank you. You got to press
Yeah.
modules and then go to the module 2 and you'll see it there. Okay, so we've got a plan. If you need help with anything between now and Monday, don't hesitate to ask me. I've been doing Zoom meetings for tutoring with some students over this week. So I do not mind helping you at all. You just have to contact me and ask to set up a Zoom meeting and we can do that. The more you practice with this, the better you get. Okay, guys, got anything else? Or are you ready to go? We good?
Yeah, I'm good.
Have a good day.
We're good.
Thank you. All right, y'all stay healthy. I will see you Monday unless you ask for a Zoom meeting before then. Have a good day.
Thank you, you too.
Bye-bye.